So we're going to get started, you guys, with our introduction to limits. So this is starting the calculus unit. This whole first chapter is about limits. So we're going to explain what limits are. Limits are a very important topic. It's a basis for all of calculus, really. So we need to understand this concept of what it means to have a limit, to be a limit, and what that talks about. So we're going to first start today by finding a limit graphically. And this is a very good way to visualize what a limit looks like. So you're going to look at every graph and you're going to ask yourself this question. What is the y value? So your limit is always asking about the y value that the curve is approaching as the x value approaches c from both the left and the right. That's the limit of the function. So again, that y value is the limit. It's the y value that it's approaching from both the left and the right. That's sort of our basic definition of what a limit is. So let's look at this first example. All right, so you guys just did a million graphs yesterday, so you are good to go with this guy. First step, we're going to factor, and we're going to notice right away that one of those factors cancels out. As soon as that cancels, that gives us a whole. And as we practiced yesterday, you change the sign to a positive 1, and then you plug it back into the remaining function, 1 plus 1, which is 2. And so I have a whole at 1, 2. Then I'm going to graph the rest of this graph, which is really just whatever's remaining. So whatever's remaining is x plus 1. That's a linear. It's a line. Y-intercept at 1, slope of 1. It's going to go right through my hole. So there's my graph. Okay, so there's my basic graph. So now we're trying to find the limit. This is the notation you're going to see. So you'll see LIM, which stands for limit. Right underneath it, it says x and then an arrow 1. What that says is as x approaches 1. Okay, so that's all that this is meaning. And we assume as x approaches 1 from the left and from the right. That's what it's talking about, both the left and the right, from both directions. As my x value is approaching 1, what is the limit, which is the y value? So I'm going to look at my graph here. And as my x values are approaching 1 from the left, they're going toward 1. And from the right, they're going toward 1. What is the y value? So over here on my y-axis, what's the y value that my graph is approaching? Well, the y value is obviously just wherever this hole is. So that y value is just this number 2. I'm approaching 2 from the right, approaching 2 from the left. And so the answer is my limit is equal to 2. Again, it's the y value of the function that it's approaching from both directions as my x value approaches 1. And that's all that a limit is. Okay? We can also find that same limit in a method called numerically. So to find a limit numerically, you draw a table of values. And again, you're going to choose x values that are getting closer and closer and closer to the x value that you want. Again, we're looking for that x value of 1. And from the right as well. So values that are getting closer and closer and closer from the right, values that are getting closer and closer from the left. Now, this is one of the only things you guys are going to use calculators for in this whole chapter. We really don't do a lot of calculator stuff. So you would go into your calculator and you'd type in this function, x squared minus 1, and make sure you're using parentheses, divided by x minus 1, and then I want to go over to my table. Okay, now I have this on my second table setup. I am on ask. So then what I can do in my table here is I can just type in any values. So 0.75, 0.9, 0.99, 0.999. Next one is 1. Then I'm at 1.001, 1.01, 1.1, and 1.25. So again, I can type in any values I want here, and then I can get those y values, and I'll type them into I'll write them in my chart now. So this was at 1.75, 1.9, 1.99. Notice my numbers here are getting closer and closer to 2. But at 1, that's a question mark, it's just an error, right? It doesn't exist. There is nothing at 1 because we know it's got the hole there. And then I continue from the right here. So this one was at 2.001, 2.01, 2.1, and 2.25. So again, from the right, these are also approaching So notice the arrows, I'm getting 1.999, 2.01, I'm getting really close to 2. So this is where my limit is 2, okay? So what we say, let me talk about notation for a second. Notice how this has this little negative right there to the right of 1? What that is saying is it's saying as x approaches 1, that little negative symbol right there, all that means is this, from the left of 1, or values that are below 1. So from the left, looking here, what number, what y value, f of x, that's my y value, is approaching 2, right? 1.75, 1.9, no. Now this little plus sign in this next one means the opposite. It means from the right. So the little plus means from the right, the little minus means from the left. So this is values above. So from all these values, well again, 2.25, 2.1, 2.01, 2.001, I'm getting closer and closer and closer to 2. So since from the left I'm getting closer to 2 and from the right I'm getting closer to 2, that means my overall limit is 2. It has to be the same from the left and from the right in order for that to be a limit. Okay? Let's look at some that are one-sided, that aren't the same from the left and from the right. So this graph, square root of 4 minus x squared, remember doing that one yesterday? That was I had to correct a bunch of you on this, guys. This was the semicircle at -2, 2, and 2. Okay? So now, let's talk about this limit that it's asking me for. It's asking me for the limit as x approaches -2. This little plus sign means from the right. So from the right, I'm approaching -2. So I'm going this way, this way, this way, this way. What's the y value that I'm approaching? I'm getting really close to a y value of, right here, 0. Okay, it's getting closer and closer and closer and closer and closer to 0. That's from the right. Well, how about from the left? Well, there's nothing over here on the left. There's nothing, -3, -4, there's nothing over here. So am I approaching anything? Well, there's nothing there. So if there's nothing there, this is what I would call a does not exist. So this, yes, you guys can all laugh at the Mean Girls quote, the limit does not exist. It's true. In this case, the limit from the left-hand limit, does not exist because there's no values there. So it can't approach anything. So we just write DNE. Okay. Now, what about the overall limit here? That means you have to look at from the left and from the right. Well, since from the right it was 0, but the left does not exist, those are not the same. And so my overall limit does also not exist. Okay, the left and the right have to be the same. So there is no limit here at x approaches -2. Okay, let's keep going. Next part, the existence of a limit. This is what I just talked about. So all that this is saying, and you know what, there's a little typo here. Let f be a function and let c and L be real numbers. The limit of f of x as x approaches c is L if and only if. Now this is supposed to have a negative right there. So what that's saying is that from the left it's equal to L and from the right it's equal to L. So what I'm saying is that my left-handed limit must equal the right-handed limit. And if those aren't equal, then you don't have a limit. The limit does not exist. All right, let's continue to practice here, finding some of these now graphically. So we're going to do a lot of piecewise graphs. Okay, so you guys got to get in the habit of graphing these piecewise graphs. So this first one, f of x equals 1 when x doesn't equal 2. Well, f of x equals 1, that's just a horizontal line at y equals 1. So it's everywhere except at x equals 2. So I'm going to put a hole there because it's got to equal 1, f of x equals 1, horizontal line, but not at x equals 2. So what's happening at x equals 2? Well, the second part of this piecewise says at x equals 2, f of x is equal to 0. That is just the point. That's the ordered pair. 2, 0. That's my x value. There's my y value. So at 2, 0, I put a point. Okay, so we have a line with a hole in it and then a point down here. Let's find the limit of this function now. So I want to find the limit, and this is, we just didn't write it on here, but this is what I want to find. The limit as x approaches 2, okay, of this function. I'm going to skip the numerical part for this one because we already graphed it, so I don't care about the numerical part as much. But let's just look at it graphically, okay? So what is the left-hand limit here? Well, as x is approaching 2 from the left, so from the left, from the left, from the left, from the left, what's the y value I'm close to here? Well, I'm equal to it. I'm equal to 1, 1, 1, 1, 1, 1, 1. So my y value is 1. How about from the right? Well, again, what's the y value for all these points over here? The y value is 1. So my overall limit as x is approaching 2 from both directions, from the left and from the right, it's equal to 1. So my overall limit is equal to 1. Now this is an interesting case because the limit as x approaches 2 of f of x is equal to 1. But what is f of 2? What's the value of my function at 2? Well, the value of my function at 2 is equal to this point right here, which is 0. So my function value is not equal to the limit necessarily. So I'm going to write here a little note, not necessarily equal. Now, sometimes your function value and the limit will be equal, but a lot of times they're not going to be the same. And you can have a limit that's different from the function value. Okay, I'm going to pause it there for part 1.